The well-fed state can be referred to in two other terms: the absorptive state and the postprandial state. This is really important. You make all three are synonymous: well-fed, absorptive, postprandial. Postprandial, well-fed, and absorptive are synonymous. They all mean the same thing, the well-fed state. Usually that describes the state you're in within 4 hours after a meal. Okay? Characteristically, what you will have is plentiful nutrients. You'll have proteins, carbohydrates, you'll have lipids from the diet. All of them are going to increase amino acids, glucose, chylomicrons, respectively, in the bloodstream. Okay? So you have everything you can use from the diet in the bloodstream. It's all available in abundant amounts. Most importantly, because of glucose in the bloodstream, you're going to stimulate insulin secretion. So in the well-fed state, insulin really is going to control essentially all of metabolism. Okay? And we said insulin is primarily an anabolic hormone. So you're going to promote the synthesis of glycogen from glucose. You're going to promote the synthesis of tags from fatty acids. You're going to promote the synthesis of proteins. So all anabolic processes will be activated. Now, you say, what glycolysis? Glycolysis will be activated as well to generate energy from glucose. The reason being, there's plenty of glucose. In the well-fed state, glucose is the primary source of energy for all tissues. Okay? That's a good thing, good rule of thumb. Glucose is a primary source of energy for all tissues. There's plenty of it. So they will consume glucose in each and every way they can consume glucose. You consume glucose through glycolysis and glycogen synthesis. So the liver will consume glucose for energy through glycolysis and to synthesize glycogen for later on, to store for later on. Okay? Importantly, the liver is going to use nearly 60% of all the glucose in the bloodstream. Okay? Just that little organ, liver, will use nearly 60% of all the glucose in the bloodstream. Okay. There are also effects of insulin on different tissues. Insulin is going to affect muscle and adipose tissue. We just talked about yesterday that insulin increases uptake of glucose into these tissues specifically. Okay? So that's very important to be mindful of. The specific increase in glucose uptake in muscle and adipose tissue. But I want to go to what happens with each tissue. And that simplifies it a little bit for you. So we said there's plenty of glucose in the diet, plenty of glucose. This should be glucose in the bloodstream. In the well-fed state, glucose is taken up not in an insulin-dependent manner, but because it's high in the bloodstream. You increase blood glucose, increase uptake in the liver. You also have plenty of amino acids from the diet. Increase uptake as well. Again, glucose use in the liver. Two distinct ways. Glycogen synthesis, glycolysis. You can even use it in the HMP pathway. Excess pyruvate and acetyl-CoA here can be shunted to make fatty acids. Fatty acids will make tags. Tags will be packaged into VLDL. Amino acids that are taken in, note their fate. Their main fate really is going to be here. To make protein, muscle proteins, enzymes, structural proteins. Any excess amino acids can be metabolized to give you energy, but there's no storage of amino acids. So you're going to have, so you use them primarily to replace muscle, liver proteins that were degraded or broken down. And the third component here, this is the tag-rich dietary component, chylomicrons. They're going to provide additional fatty acids to the liver, and some of these fatty acids will be stored as tags in the form and released in the form of VLDL. So the important effects here of insulin is to stimulate glycolysis, to stimulate glycogenesis, and fatty acid synthesis. Okay? Also importantly, you're going to make tags from fatty acids. What you need is glycerophosphate, and glycerophosphate, the backbone, comes from DHAP from glycolysis. And since glycolysis is very active, there's plenty of glycerophosphate to make tags here.
Glucose provides two important precursors needed for the synthesis of triacylglycerol. The first one is dihydroxyacetone phosphate, which provides the glycerophosphate backbone for the synthesis of triacylglycerol. The second one is pyruvate, which provides the acetyl-CoA for the synthesis of fatty acids. Two fatty acyl-CoAs are sequentially condensed with glycerophosphate to produce phosphatidic acid, which then is converted to diacylglycerol by a phosphatidic acid phosphatase. A third fatty acyl-CoA is condensed with diacylglycerol to form triacylglycerol.
So all in all, you have these what we call anabolic effects, building large glycogen from glucose, tags from fatty acids, and proteins from amino acids. The next important tissue is adipose tissue. I don't have much on this on adipose tissue, but I'm going to say a couple of things about it a little later. But first of all, I want you to appreciate one important thing. So this here is the adipocyte. This small part there, the green oval shape, is the cytoplasm. The red is the nucleus. This entire yellow 90% of the cell is tags. Okay, so this is our storage of tags in adipocytes. So their main function now in the well-fed state is to just store more tags, because there's plenty of glucose, there's plenty of fatty acids. They're gonna make more tags and store them in adipocytes.
With increased glucose uptake and glycolysis, there's plenty glycerol phosphate to serve as a backbone for tag synthesis. Simultaneously, lipolysis will be inhibited due to the dephosphorylation hormone-sensitive lipase. In muscle, the metabolic changes are similar to those of the liver, which includes increased glycolysis, increased glycogenesis, inhibition of glycogenolysis, increased protein synthesis from amino acids. In addition, muscle and adipose tissue will increase their uptake of glucose from plasma through the increase in GLUT4 transporters on their respective surface. By specifically increasing the number of glucose transporters, GLUT4, on the surface of these two tissues, muscle and adipose tissue will pick up glucose from the bloodstream in an insulin-dependent manner. These two tissues constitute a significant portion of body mass, and as such, they can contribute to a significant amount of uptake of glucose from the bloodstream, reducing the amount of glucose in the bloodstream. This effect of insulin is specific for muscle and adipose tissue only. With plenty of glucose in plasma in the well-fed state, the brain is quite happy picking it up and using it exclusively for its own energy needs. If you like this video, please subscribe. Thank you.